everyone. So today we are going to solve some questions that came in your 24 JEE Main exam in the morning session. My name is Anjali Yadav, chemistry faculty from Infinity Learn. Let us begin. Let's look at the first question over here that came. The first question is the statement 1. Hybridization shape, spin only magnetic moment of the compound that is given to you, the complex compound, is sp3d2 octahedral and 4.9 Bohr magneton respectively. So we have to find out its hybridization. We have to find out if it is octahedral or not, which we can clearly see from here itself that it is going to be an octahedral compound, which is absolutely right. That is not a problem. Next, we have to also check with respect to the 4.9 Bohr magneton. So quite honestly, you can find out the magnetic moment with respect to the number of unpaired electrons that are going to be present here. Okay. So let us start. Let us look at first one, which is going to be, if you look at the configuration, so this is going to be cobalt plus 3. This is going to be cobalt plus 3, right? Because it is cobalt plus 3, it is going to be 3d6. Now also you have to see over here that CO3 is actually a bidentate ligand. Apart from being a bidentate, it is a weak field ligand. Okay, so this is a weak field ligand. So when we are going to fill the electrons in the d orbital of cobalt, 1, 2, 3 and 4. So 1, 2, 3, 4, 5, 6 pairing is not really going to take place over here, right? So we are going to have the next orbital that we will have to consider for its bond formations. Okay, so we have sp3 and d2. Because we need 6, because it is a bidentate ligand, weak field bidentate ligand. Okay, right? So hybridization is absolutely fine. It is octahedral. Let us look at the number of lone pair of electrons. There are 4 lone pair of electrons, and if we put in the formula for it, we are going to get n plus 2. That means if you calculate this, which is going to be 4 plus 2, you will get somewhere between 4.9, right, which is already given to you over here. Okay, so that means the first statement R is absolutely correct. Let's look at the next statement. The next statement says that the geometry hybridization spin only magnetic moment values for the ions that are present over here respectively are square planar, tetrahedral, octahedral, dsp2, sp3, sp3d2 and 0, 5.9, 4.9. So in a similar way, we have to find for these compounds as well. As you can see over here, looking at the oxidation state, nickel is going to have +2 oxidation state, and hence it is going to be 3d8. Manganese over here is going to also have +2 oxidation state, so it is going to be 3d5. Cobalt is going to have +4 oxidation state. So it is going to be 3d6. Actually, if it is +4 oxidation state, it should be 3d5. 1 second. So tiny correction over here. It's not 3d6, it is going to be 3d5. Okay, let's look at the values that are presented to us over here. So, and we can talk about. So, first of all, we are going to identify the ligand that has been given. The ligand that is given over here is a strong field ligand, right? So, that means pairing is definitely going to take place over here. And if we make down the d orbital, right, for this one, 1, 2, 3 and 4, 1, 2, 3, 4, 5, 6, 7, 8. Okay. After that, because the pairing is going to take place, it is going to come down till over here, and when it is going to come down to the other position, as you can see, we do have a d orbital that is present. After that, we are going to have s, and after that, we are going to also have p orbital that might be present. So here, because of the pairing, because of having a low spin and strong field ligand, so let me make it on the other side. Okay, yes. So it is going to be exactly what is given to us, which is D, D2, DSP3. DSP3. So yes, it is dsp3. How many unpaired of electrons are there? There are 0 unpaired of electrons, so Bohr magneton is going to be 0 over here, right? It is, what else was given? It is going to be square planar. Yes, it is going to be square planar because that is the configuration, hybridization for a square planar complex. So this is square planar. So for, as per as this compound, this complex, everything is correct. Let's look at the next one over here. I'm just going to take some space. So here we have been given a weak field ligand, right, which is your bromine. So we have a weak field ligand, right? Let us put down the electrons now. So pairing is not going to take place over here. 3 and 4. 5 electrons have been put. 1, 2, 3, 4 and 5. So rest of them are actually going to go for hybridization. So we are going to have sp3 hybridization. So sp3 hybridization meaning it is going to be tetrahedral, and because it is tetrahedral over here, how many lone pairs of electrons are there? There are 5 lone pair of electrons. So its spin only magnetic moment is going to come out to be 5 point something, and this is one of the tricks that is very useful. So whenever looking at the number of unpaired electrons, you can get the first digit of your magnetic moment, right? Spin only magnetic moment. So as you can see over here, if we have 4 and 5 unpaired electrons, so number is definitely going to start with 5 itself, right? 5 point something it will be. So this will give you a really nice edge. So it is going to save you a lot of time, because calculating under root, why do we have to waste that much of time, right? So it is going to be 5 point something. And what is given in the question? 5.9. So absolutely right. No problem. If you do want to do the calculation, definitely go ahead. You are going to get 5.9. Okay. Let's look at the last one. In the last one also we have 3d5. And also we are going to have over here a weak field ligand that has been given to us. So again, as you can see, but this time what they have given us is a octahedral species, right? So 1, 2, 3, 4, 5, s orbital, p orbital, and after that we are going to have a d orbital. So this is going to be sp3 d2. Okay. Again, how many unpaired electrons do we have? Actually here, I think, one second, cobalt, yes, it is going to be 4. 4 electrons, sorry. So let me just make a tiny correction over here. Not 5, but 4. I think there is some problem. It's cobalt Fe6 2 minus. Either it has to be 3 minus so that we can have cobalt plus 3 config. One second, I'll just check it over here. Otherwise, the answer should be correct. I think there is one problem that is given to us. I'm just going to make that tiny correction over here. This is going to be 3 minus, not 2 minus. Okay, so we are going to have plus 3 combination, and now it is going to be right. Okay, so this is supposed to be 3 minus. So we are going to have cobalt, which is going to be plus 3. Okay, and if we have plus 3, this is going to be then 3d6 as it was given. Okay, so we are going to have over here plus 3, right? This is also 3 minus. Okay, and we are going to have a weak field ligand like I've given to you before. Why is it not coming? Wait, it's coming there. One second. So 1, 2, 3, 4, 5 and 6. How many unpaired electrons do we have? We have 4 unpaired electrons. If we have 4 unpaired electrons, our Bohr magneton over here is going to come out to be 4 point something, 4.9. Okay, so yes, everything is absolutely fine over here. Statement 2 is also going to be correct. Just a tiny correction over there for the last one. 4 cobalt plus 3. If you are given 2 minus, then it is going to be cobalt plus 4. Please remember that, right? And then your values are going to change over here. But this is going to be true if the question is like this. Okay. So let's look at the next question, question number 52. Question number 52 is given below are statements about some molecules and ions. Identify the correct statement. So first of all is dipole moment of NF3 is higher than that of NH3. So let us write down the structure over here. Both of them definitely are going to be pyramidal itself. One lone pair of electron over here. For ammonia also pyramidal with one lone pair of electron. Right. Now, if you are going to look at the dipole moment, right, if you are going to look at the dipole moment, we have to make a generalization over here, general idea that of course fluorine is going to be more electronegative, is going to move towards fluorine, here also towards fluorine, here also towards fluorine, and towards lone pair. So that means one of them is going in the opposite direction, but here we have all of them going into the same direction, which is upward. So this is kind of unanimous over here. That means your NF3 is definitely not going to have higher value. It is going to have lower than that of ammonia. Okay. The dipole moment value of BeH2 is 0. If you are looking at BeH2, the dipole moment is absolutely 0, which is correct because it is going to be linear in shape, right? So both the side, as you can see, Be, hydrogen and hydrogen, dipole moments are going to cancel out each other completely. The bond order of O2, 2 minus and F2 is same. The bond order is going to be same as long as you have the same number of electrons. Okay, if you have the same number of electrons, the bond order value will come out to be same. So let's look at the number of electrons that are present in O2 minus. There is going to be 16 plus 2 from the charge, 18 electrons, and here also there is going to be 9 plus 9, 18 electrons. So because they have the same number of electrons, the bond order will be the same. So correct. The formal charge on the central oxygen atom of the ozone is -1. When you are going to calculate the formal charge over here, oxygen, double bond oxygen, there is one lone pair of electron that is present on the oxygen that is present in the middle. Let's calculate the formal charge. So how do we calculate formal charge? First is valency, which is 6, minus lone pair, which is 2, and minus number of bond pair, which is 6, divided by 2. Okay, so this is going to be plus 1. Okay, plus 2 actually, isn't it? So we have 2 and this is going to be 3. Okay, plus 1. Plus 1. Right? So this is not -1, this is actually plus 1. Okay. Next is in NO2, all the 3 atoms satisfy the octet rule, hence it is very stable. Do all the 3 atoms satisfy the octet rule? If you look at the NO2 structure, again it's very similar to the ozone itself. The nitrogen over here has, as you can see, 1, 2, 3, 4, 5, 6 and one lone pair of electron is present over here. So it has 7 electrons. For this oxygen atom, yes, it is satisfying the octet. Here there are 8 electrons. For this oxygen also it is satisfying the octet. There are 8 electrons. For nitrogen, not really. So that means all 3 are not having the satisfaction of an octet rule, only the 2 oxygen atoms. So B and C are only correct. So correct answer is 1. Okay. Next question is question number 53. So question number 53, there are several anions that are given to you over here. Oxygen atom with the negative charges. There is also one with a lone pair of electrons. So what do we see over sorry. So what do we see over here? We are going to look at the combination in decreasing order of stability. Right, for stability, if you are looking for an anion, what do we need? We need an electron withdrawing group. We need a -I group to be present with it, right? Because of that combination, the best one is going to be over here, the 4th one, right? After that, the next one is going to be OCHO group is present over here very nicely. So the 4th one is going to be the best. After that, the next one is going to be the electron withdrawing group bromine, I can see. The next one is going to be the 2nd one over here, right, on the benzene ring, not very stable. After that, the next and the last one is 3rd one. Okay, so that means the correct answer is going to be 4th. Let's look at the next one. So we are looking at the decreasing stability, which is absolutely fine. Let's look at the next. Correct stability order of the following diazonium salt is, when you're looking at the stability order, you have to look, first of all, let me write down the alphabets. This is A, B, C and D. Okay. So for a diazonium salt, it is going to be more stable if it has an electron donating group with it, right? How many electron donating? We have only OCH3, that is electron donating. Nitro is electron withdrawing, CN is electron withdrawing, and 1 is with no one. So we have A, which is definitely going to be more stable. After that, the next one is going to be D with no substituent. Then the next one is going to be CN, right? Cyanide. Sorry, did I write C? Sorry. So we have A, C, and in the last one, as you can see, we have the most electron withdrawing group, which is nitro, which is definitely not going to be very stable for it, and that is why the correct sequence is going to be 3. Okay. So next is diazonium stalls stabilized by electron donating groups. Next is, among the following, the correct combinations are. Now this is the kind of a question that can be answered very easily with respect to if you are able to calculate the steric number easily. Okay, so you should have a good grasp on steric number, and this kind of a formula I think we have done so many times in our classes. You must have done a lot of questions on this, so it should be pretty easy, right? So let's look at the first one over here, which is IF3. Let's find out the steric number, which is Z, so that we can get the hybridization as well as the shape over here to find out the number of lone pairs. Okay. So first of all, it is going to be 7, which is the valency of iodine over here. There is one monovalent atom, so plus 3 divided by 2. So that means it is 5. How many lone pairs do we have for this one? For this one, the number of lone pairs that are present is going to be 5 minus 3. That means it is equal to 2. Right, so it could have been pyramidal, trigonal, bipyramidal. Of course, because it is 5, so it is going to be sp3d hybridized, so that is completely fine. Next is going to be, because there are 2 lone pair of electrons that are present over here, so that means it is going to have T shape, which is correct, right? So this is absolutely fine. Let's look at the B one, right? So it is going to be 7 plus 5 divided by 2, this will be 6. So that means it is going to be sp3d2. We do have one lone pair also that is present. So lone pair is going to be steric number minus the surrounding atom, which is 5. So 1. So square pyramidal, this is also correct. Let's look at the next one, which is IF7. IF7 is going to be 7 plus 7 divided by 2. This is going to be 7. And how many lone pairs do we have? We don't have any lone pair of electrons as such, right? So 7 minus 7. So pentagonal bipyramidal sp3d3 hybridization, which is also right. Let's look at the last one over here, D, which is going to be ClO4 minus. For ClO4 minus, we have chlorine with 7 plus 1 for the negative charge. There is no other halogen or monovalent atom that is present, divided by 2, so this is going to be 4. If it is 4, it should be sp3 hybridized, right? How many lone pairs do we have? We have over here 0 lone pairs, because 4 minus 4 is going to come out to be 0. So it should be sp3, it should have been tetrahedral, right? And that is why, so sp3 and tetrahedral. So last one is correct. Correct answer is A, B and C only. Let's look at question number 56. Question number 56 is pretty interesting, because what they have done is that it's a very simple concept and they have tried to play with it a little bit. So if you see that delta H is positive or delta H is negative, that means negative, meaning energy has been released, right? Energy is released. What does that mean? That your reactant was actually over here at a lower value as compared to the product, right? Or as a lower value with, please don't get confused over here with respect to the symbol. That does not mean the reactant is less than product. The reactant energy is less than the product energy, okay? Right? From the, when we are moving from A to B. So we have to look for someone where the product energy is higher, right? Which is present over here. Which is present over here, as well as it is present over here as well. So this is still here, it is fine. Sorry, it is positive. I'm really sorry about that. So I'm looking at B to C, I'm talking about A to B. If it is positive, that means energy is absorbed. that means the reactant must have a greater energy than the product. If the reactant has a greater energy than the product finally, and this is also negative, that means energy is negative, so that means finally it should be in such a way that your final reactant to product, the product should be in higher energy and the reactant should be lower. Between C and D also it is negative, that means reactant is less and the product is more. And overall A to D, it is going to be negative only, right? And because it is going to be negative, so reactant is going to have lesser and product is going to have a higher energy. Looking at the values that has been presented to us, right, I think the correct one is going to be the fourth one over here. Okay, so how the graph is going to go from A to B, B to C and C to D, this is very nicely represented over here in the option 4. Let's look at the next question. Given below are two statements, carbon-chlorine bond is stronger in CH2 double bond CHCl. Think about it. Of course, there are lone pair of electrons with respect to the chlorine atom that are present very nicely. In fact, 3 lone pair of electrons that are present over here. There is also a double bond that is present, so there is a chance of resonance, right? And if you have resonance, that means the carbon-chlorine bonds are going to be over here larger, okay, sorry, smaller. And the first statement, and stronger also, so the first statement is correct. Let's look at the next statement. The given compound is optically active. Whenever you have a chiral carbon atom, asymmetric carbon atom, that means the carbon atom which has 4 different substituents present on it, it is going to be optically active, provided there is no plane that can pass through the compound that can divide the compound into 2 equal half. So plane of symmetry as well as asymmetric carbon atom. Here there is just one carbon atom, so we will talk about asymmetry very nicely. There is asymmetry that is present, that means it is optically active. So both the statements are true. Question number 58 is a very simple and a basic question. Vinyl chloride, benzyl chloride, alkyl chloride and allyl chloride, right? So first one, as you can see, is going to be vinyl chloride. That means the halogen is attached directly to a double bond carbon atom and it is in a alkane chain. So correct is 3. Then we have benzyl chloride. Of course, looking at benzyl chloride, the benzene ring is already very nicely provided to us over here, and there has to be one carbon atom between the double bond carbon atom and the halogen, which is given. Alkyl chloride, that means in a plain simple chain over here, right? And after that, it is also going to be that the double bond carbon atom, between the double bond carbon atom and the atom, there is going to be one difference. So that is going to be 2, and then we have allyl chloride, which is going to be 1. So one correction actually, that is allyl, where we have one carbon atom between the halogen and the double bond. Here it is going to be double bond that they forgot, I think, one double bond here, right? So if it is directly attached, and I think one more thing they could have given here, a cyclic ring, that would have been much better. But I think there is a little bit of a problem with the question. Otherwise, with respect to what is given to us, yes, option 4 is going to be correct. Okay, but yes, for allyl and benzyl, we should have them present as a part of a chain, which is not given. That is okay. Let's look at the next one, question number 59. Question number 59 talks about consider a mixture X which is made by dissolving 0.4 mole of compound, this compound, and 0.4 mole of other compound in water to make a 4 liter of a solution. Okay, when 2 liter mixture of X is allowed to react with excess of AgNO3, it forms a PPT-Y. The rest 2 liter of the mixture react with excess of BaCl2 to form precipitate Z. Which of the following statement is correct? Let's see over here how we are going to solve this question. So first of all, we are going to write down the 2 equations, right? How your compounds are going to dissociate. So when it dissociates, as you can see, it is going to dissociate as Br minus. Both the Br minus are the ones that are going to actually react with your silver nitrate to form silver bromide, which are going to be as a PPT. Now, of course, if this was present as 0.4 mole, these two are going to be of 0.4 mole itself. 2 liter of this is 4 liter, but 2 liter of it is taken out. That means half of volume is taken out, half of volume, that means half of mole must have been taken out. So that means 0.2 mole of Br minus and 0.2 mole of SO4 2 minus. I think, one second. 2 Br minus neither, there should be SO4. One second. I'll just make a tiny correction. The next compound was actually SO4, right? Yes. This is Br4 and this is SO4. Okay. So here we are going to have Br4 and here we are going to have SO4 2 minus. This is SO4 2 plus. Now it is better. Okay. I think I had written the same thing twice. That was the problem. Alright. Now let's see. This is ammonia 5. Ammonia 5, then this is going to be, why I'm writing 4 for bromine. Sorry about that. Yes. Now I think everything is fine. Let us move on. Right. Br 6 and F is a 4. Right. 2 plus and 2 minus. This is 4, okay? Let's see. So here, of course, we are going to be taking out 0.2 mole of Br minus, 0.2 mole of SO4 2 minus. 2 liter mixture, when it is going to react with the AgNO3, it is going to make AgBr, which is going to be as a precipitate for 0.2 moles. Now here we will have BaCl2, which is going to form BaSO4, which will precipitate as 0.2 moles. So that means for both of them, we definitely have 0.2 moles, right? So correct answer over here is second, which is 0.2 mole of Z is formed. Okay, let's look at the next question over here. The next question is, consider 3 metal chlorides X, Y, Z, where X is water soluble at room temperature, sparingly soluble at room temperature, Z is soluble in hot water. So this is a very concept based, memory based question coming from your inorganic chemistry part, right? So here the correct answer is going to be 2. Copper chloride is soluble at room temperature, silver chloride is sparingly soluble at room temperature, and over here lead chloride is soluble in hot water. Let's look at next question. A student is given one compound among the following compound that give positive test with Tollens reagent. Who gives a positive test? First of all, one is very simple, aldehydes, right? Apart from that, who else can give you Tollens test? Hemiacetal can give you a Tollens test. And where can I find a hemiacetal over here? The hemiacetal is given at position C, and that means 3 is going to be the correct answer. Okay, hemiacetals give Tollens test. Next is question, consider the following reactions A and B. Here a phenol compound, sodium main product, and a gas is given. They want us to identify the gas in both of them, sodium and sodium hydrogen carbonate. Numerical value molar mass for X and molar mass of Y is which of the following? So let us start over here. First of all, when phenol is going to react with sodium, it is going to make ONO, and here it is going to make COONA, right? That is fine. The gas that is released is hydrogen over here. The gas that is released over here is going to be carbon dioxide, right? Hydrogen mass is, this is how I've already written down over here. Hydrogen is the gas that we are talking about, and over here we are talking about carbon dioxide that is being released out. Okay, these are the two gases. When these gases are going to be released out, as you can see, what is the molar mass of H2? Molar mass of H2 plus molar mass of carbon dioxide is what they want to calculate. So it is going to be 2 plus 44, right? It will give you 46. So correct answer should be 46. Next is question number 63. Question number 63 is the number of paramagnetic species among them is. So of course, again, you will have to write down first configuration. Then you will have to see if the ligand that is given to you is a weak field or a strong field ligand. According to that, you have to arrange the elements and see if there is a paired, unpaired electron. How many unpaired electrons are there? Okay. So let's see for the first one itself. We have 3d6 because it is going to be cobalt plus 3. Here it is going to be titanium plus 3. Vanadium is going to be over here with respect to plus 5, right? Plus 5. And here we are going to have iron with plus 3 config, right? So electronic configuration is going to be 3d6, 3d1, 3d0. If it is 0, then definitely not paramagnetic. So here itself I can cancel it out. For this one, it is a weak field ligand, right? If it is a weak field ligand, if put the element in the D1 1, 2, 3, 4. I think I put one extra. Okay, let's see. 6 electrons, 1, 2, 3, 4, 5, 6. 4 unpaired electrons, so paramagnetic. 1 unpaired electron, paramagnetic. And here also, if you see, this is a strong field ligand, by the way, right? If it is a strong field ligand, 1, 2, 3, 4, 5, 1 unpaired electron is still there, and because 1 unpaired electron is there, this is also going to be paramagnetic. So 3 should be paramagnetic, and which is already given to you over here, 3, so this is correct. Next is the statement that these are arranged, right? And we also have Cl, okay, so this is the same one, right? Is the correct order in terms of the number of unpaired electrons present in the complexes. So let's look at that as well. So as you can see here, iron is going to have a +2 config. Here it is going to have +3 config, plus oxidation state. Here it is going to have +3 oxidation state. 1 second. +2, and here also it is going to have +3, right? The only difference is that in here is with respect to your strong field and a weak field ligand. So as you can see, this is going to be a strong field ligand, this is going to be a strong field ligand, this will be a weak field ligand, and this also will be a weak field ligand with respect to the water that are present, okay? Right? So let's see over here, if we have iron 2, I mean 3d6, right? So how many unpaired electrons? They want us to calculate the number of unpaired, right? So let's do that. 1, 2, 3, 4, 5, 6. So we have 0 unpaired electron for this one. So it should have least, which it does. Let's look at the next one. Next one is 1, 2, 3, 4. So 1, 2, 3, 4. 5, 1 unpaired electron. Next one, it's a weak field ligand. So it will be 1, 2, 3, 4, 5, and 6, 4 unpaired electron. And this is also a weak field ligand, as you can see, but this is 3, 5. So 1, 2, 3, 4, 5. So there are 5 unpaired electron. So yes, absolutely, that is correct. The sequence is absolutely fine over here. We have 0, 1, 4, and 5 unpaired electrons that are present over here. So the order is absolutely correct. Both the statements are fine. Answer is A. Question number 64. Given below are 2 statements, and potassium is more than magnesium, aluminium, boron is correct order in terms of the metallic character, which is absolutely correct, no problem at all, right? Of course, we are looking at down the group as well as across the period over here. Next is atomic radius is given. So when you are moving from left to right, the metallic characteristic is going to decrease. When you are moving from top to bottom, the metallic characteristic is going to increase. So according to that, this is completely good. Next is statement 2, atomic radii is always greater than the ionic radii for any element. Atomic radii is always greater than the ionic radii. Not really. Specifically when we are talking about cations and anions, it is not going to be always greater. Anionic radius is going to be greater for any anion, right, as compared to the atomic radii. So second statement is not correct. So question 4, this is going to be false. Question 65 is, a solution is prepared by dissolving 0.3 gram of non-volatile, non-electrolyte solute A. Molar mass is 60 gram per mole, and 0.9 gram of non-volatile, non-electrolyte solute B of molar mass 180 gram per mole in 100 ml H2O at 27 degrees Celsius. Osmotic pressure. Easy, easy, easy. Osmotic pressure is asked to you over here. So that means first thing first, we have to collect the concentration over here. What was the formula for osmotic pressure? Pi is equal to CRT, right? How do I calculate the C over here? I will have to combine the two that are present. So I will have to first write down the number of moles divided by volume, because I'm talking about concentration. I'm going to add for both of them that are given, both the compounds A and B, right? And we will put the value of R, we will put the value of temperature. So let us see how, right? As you can see over here, this is mass by molar mass divided by volume. Volume is given to us in, I think, where is it? ml, so we are going to convert in liters, Okay, so this is mass by molar mass, mass by molar mass. Over here also mass by molar mass of the B1, and over here this is going to be volume in liters. After that R, and this is T for temperature, and you will get 2.46. So I think pretty simple equation as long as you remember the formula well. Okay, let's look at the next question. Question number 66. Okay, a hydroxy compound with molecular mass 122 gram per mole is acetyled with acetic anhydride using a large excess of reagent, ensuring complete acetylation of all hydroxyl group. The product obtained has a molecular mass of 290. The number of hydroxyl group present in compound A is how many? I think one option is missing. Okay, nevertheless, that wouldn't have been the right answer. Let's see over here how we are going to write it down. First of all, what they have given, hydroxyl compound with molecular mass is acetylated with acetic anhydride using large excess of reagent, ensuring complete acetylation of hydroxyl compounds. So let's see that if we have complete hydroxylation, so as you can see, this is the kind of a formula that we are looking for, right? And as you can see, for every R group, the hydrogen is getting replaced by over here COCH3. Okay, I will write it down very nicely, don't worry. Each OH gets converted to OCOCH3. Okay, we are replacing hydrogen with COCH3 to make it absolutely clear. So what I'm doing over here, what is the complete molar mass of this compound? COCH3 molar mass is 43. That means for this compound specifically, how much is their increase in the hydroxyl? It is going to be 42 grams, because 43 minus 1, so it is going to be 42 grams. So number of hydroxyl group, what will the formula that we have to use? Molar mass of acetylated product minus mass of original divided by 42. What is 42? 42 is net increase in the hydroxyl group. Okay, now we just have to put in the values that is already provided to us. 290 minus 122 divided by 42, you will get the answer as 4. A tiny bit of a difficult question, because you will have to see the picture very clearly. You have to write it down in a very nice and a precise way. Your observation skills should be very good for this one. Okay, let's look at the next question then. So let me just make a tick mark over here that the correct answer was 1. Next is question number 67. Question number 67 is a pretty easy question which is going to use your Arrhenius equation, right? And let us see. At 27 degrees Celsius in the presence of a catalyst, activation energy of the reaction is lowered by 10 kilojoules, so activation energy is given. Logarithmic ratio of K catalyzed by K uncatalyzed is which of the following? Consider that the frequency factor for the both the reaction is same. If it is same, it will get cancelled out, so don't have to worry about it. Let's see how we're going to solve the question over here. So first of all, I'm going to write down the Nernst equation for it. This is A, by the way, EA RT, right? So which is, or you can write down delta E also, that is completely fine, right? So here we have catalyzed, uncatalyzed, and if I'm going to talk the log, we'll take the log value of the equation. So what will it become? Delta E 2.303 RT. Now we just have to put down the values and we will get the answer over here as 1.741. Okay. Let's look at the next question, question number 68, which is a very easy question, right? Arrange the following alkenes in decreasing order of stability. So when we are talking about alkenes, more are the number of electron donating groups that are present with it, more is going to be its stability, because more are the alpha hydrogens, right? So here, of course, looking at the first one, it's the most substituted one. Most alpha hydrogen can be found in the first, so first is going to be definitely the correct one. After that, the next one is third. We have 3 CH3 groups over here. Then second one, we have 2 CH3 group, and fourth one we have only in the we have in the cis form and trans form. So this is trans and this is cis form. So that is going to be the fourth one. So correct answer is A. Okay. Now good thing is yes. All right. Let's look at question number 69. Question number 69 is W grams of non-volatile electrolyte solid solute of molecular mass m gram per mole when dissolved in 100 ml of water, decrease vapor pressure of water from 640 mmHg to 600 mmHg. if the aqueous solution of electrolytes boil at 375 Kelvin and Kb of water is given to you, which is 0.52, then the mole fraction of electrolyte solution can be expressed as which of the following? So of course, we are going to be using over here the formula, which is going to be delta Tb is equal to I Kbm. M over here is molality, please remember. So that means the number of moles divided by mass of solvent. Okay, mass of solvent in kg, it is given in grams, so we are going to do the conversion. Moles, mass by molar mass. Now we will put down the values to find the value of I. From here we got the value of I with respect to mass and molar mass, okay, which we are going to keep it like that. Now we are going to use it in the relative lowering of vapor pressure formula, which is P naught minus Ps divided by P naught and I into mole fraction of the solute, okay. So when we are going to put down the values that are given to us, P naught is given, Ps is given, which is 640 and 600. I we have just found out, and X solute. So when we do that, X solute with respect to mass and molar mass is going to be 1.3 divided by 8. So here, and this is W by M. So correct answer is 4. Let's look at question number 70. Question number 70 over here is that they are asking a very simple formula based question to us, right? And when they are asking formula based question, reversible expansion, for a reversible expansion, oh, they haven't written the options over here, right? Let me write 1, 2, 3 and 4. The first one is going to be for a reversible expansion. That means you have to take the log value of the work done. That means second will be correct. Free expansion, that means W is going to be 0. Work done is going to be 0 in case of free expansion. Irreversible expansion and irreversible compression, you have to make sure regarding the volume what you are taking. This is negative and this is negative. When we are expanding, that means the volume is changing. Vf is going to be greater than Vi. And that is why reversible expansion is going to be this and irreversible compression is going to be the fourth one. So correct answer is 2. Okay. Let's look at the next question. The next question that is given to us is coming from your redox reaction chapter. I think very few questions have come up, but then again, still a good one. X and Y are the number of electrons involved respectively during the oxidations of I minus to I2 and S2 minus to S, acidified K2Cr2O7. And when we are talking about acidified K2Cr2O7, that means over here Cr2O7, 2 minus is getting converted into Cr plus 3, first thing first, right? Apart from that, what else do I have to see? 4, 7, sorry, right? Okay, right? So as you can see over here, this is going to be for the chromium, acidified K2Cr2O7. I minus is being converted into I2, and on the other side, S2 minus is being converted to S. So I'm going to try to write down both the equations over here at the same time, so that because we just want to calculate the number of electrons, right, the oxidation respectively. So number of electrons involved. So let us see over here. First of all, let us try to balance this equation. 2 chromium are present over here, so I will have to write down 2 over here as well. How many? So this is going to be plus 6 oxidation state for chromium. For 1 chromium, for 2 it will be plus 12. For 1 chromium it is plus 3, for 2 chromium it is going to be plus 6. So number of electron transferred in this scenario is going to be plus 6 electrons. Okay, now I have to balance the oxygens, right? So plus 7 H2O, right? Oxygen, 7 oxygen atoms. Now I have to balance H plus, so 14 H plus. Okay, so this side I have completely balanced. Let us try to balance the other two side over here as well. So this is 2 and here there is 1 and 1, so that is completely fine. Here there are going to be 2 minus as the charge. Here it is going to be 0 as the charge. So that means how many electrons are removed? 2 electrons are removed. What about this one over here? As you can see, rest everything is fine. This is 2 minus and this is 0. So here also plus 2 electrons are removed. Okay. Now what do we have to do whenever we are doing this kind of a equation? As you remember, so I'm just writing it down in a very shortcut form, okay? If you want to, you can use the half reaction method, ion method, whichever you want. I'm just writing both of them because I know they are going to react. This iodine is going to go for chromium and S is also going to go reaction with the chromium, right? If both of them, we have to write down the final equation for both of them. I know that this equation is going to be, then I have to make the number of electrons same, right? So I'm going to multiply this equation by 3 and this also equation by 3. So final equation, how will it look like for both of them? For, let's say, if I want to make it for chromium and iodine over here, it is going to be Cr2O7 plus 6I minus plus 14H plus, right? Here it is going to be 2Cr plus 3, 7H2O and 3I2. Okay, electrons are going to get cancelled out. So for your reference, I have written the complete equation. Not required to write the complete equation because in the end they just want us to calculate over here the number of electron transferred. And just looking at these numbers, I know the number of electron transferred is what? It is going to be 6 and 6. So it is going to be 12. Okay, so number of electron transferred over here is going to come out to be 12. Okay. Similarly, if you want to, you can write down the other equation, that is not a problem. CrO7 plus 3S minus 14H plus, right? And here S, this is 3S. Then we have 2Cr plus 3 and 7H2. Only for your reference so that you know how does the complete reaction looks like. But if you see the number of electron transferred, clearly 6 electrons are going to be in total for both of them. Let's look at the next question, question number 72. Question number 72 is electricity. This is a pretty longer question that has been given, but the solution is quite easy. Electricity is expressed to acidic solution of copper plus 2 till all the copper plus 2 was exhausted, leading to deposition of 300 milligram of copper metal. However, a current of 600 milliampere was continued to pass through the same solution for another 28 minutes by keeping the total volume of the solution fixed at 200 ml. The total volume of the oxygen evolved at STP during the entire process is, and all the values are very nicely provided to us to help us out really nice, right? So first of all, what we are going to do over here is we are going to write down the equation for copper 2 electrons, right, to convert into copper. Copper plus 2 to copper. Number of equivalent of copper is equal to the number of mole of electrons passed. So we are going to write down the formula to calculate the number of moles of copper, which is mass by molar mass into n factor. Mass is given, molar mass of copper is 63.52 into n factor, which as you can see is 2 from the equation. Next is the charge passed in the first stage. Charge passed in the first stage is going to be the number of electrons into Faraday, right? And as you can see, number of electrons, if you want, this is the whole thing that we have already written, so you don't have to worry about it. This thing I've written over here so that things can get cancelled out and calculation can become easier. It will come out to be somewhere 911.24 coulombs. After that, Q2 is going to be with respect to I, current and time, right? Because it is like they said over here in the question that if it was continued to pass, right, and this was the amount of current was passed for the same solution for 28 minutes, right? So we are going to use that formula over here. 28 minutes I have to convert into seconds, so I will multiply it by 60 and here we will get the answer as 1008 coulombs. This is Q1, this is Q2. So let us look at the total charge over here. Total charge is going to be Q1 plus Q2, which is 1919.24 coulombs. After that, at anode, oxygen evolves according to the equation that is presented over here. What is the most important part? 4 electrons, right? So let us look at what we can do with the 4 electrons. Number of moles then is going to be the charge divided by Faraday. 4 Faraday because 4 electrons are there, right? Total charge divided by Faraday, it will give you 0.004972 moles, which when we are going to calculate the volume for number of moles, we will have to multiply by 22.4 liters. Then you will get in liters as the answer. Since answer is asked in ml, it is going to be near to 111 ml. Okay, a difficult question, I totally agree, it takes a lot of time for this. A lot of formulas from electrochemistry has been used here. Okay, so correct answer is 111. Let's look at question number 73. Question number 73 is, consider the group 4 metals ions, which is X plus 2 and Y plus 2 solution containing 0.01 mx plus 2 and 0.01 my plus 2 is saturated with H2S. The pH at which the metal sulfide YS is precipitated is. So we have to find out pH nicely. All the values are given to us. Ka1, Ka2 for H2S is already given. Log 2 value is provided. Ksp value is given for XS and YS also. So let us see how we are going to solve the question. So first of all, we are going to start with the concentration of Y plus 2 that is given to us, right? For the Ksp value of YS, how do we write down Ksp value? Ksp value is going to be concentration of S2 minus and concentration of Y plus 2. Okay, so same I've written over there, just to rearrange it to find concentration for S2 minus out of it. Ksp value of YS is already given to the question, and from here we can find out the concentration of S2 minus. After we will do that, we are going to write down Ka1 and Ka2, which was for H2S, right? So H2S will dissociate into H plus raised to the power of 2. Let me write it down over here for extra clarity. So 2H plus S2 minus. Okay, for this equation, we have written the value. Now next is going to be substituting the values that are already given. Ka, K1 value is given, K12 value is given, H2S concentration is given, S2 minus we have just found out from here itself, and we can put down the value to calculate the concentration of H plus. As soon as you calculate the concentration of H plus over here, 5 into 10 raised to the power of minus 5, that means log 5 is what we have to take. So 5 minus log 5, log 5 value is given 0.70, you will get 4.30. Good thing about both the question, this question and previous question, although the questions were a little bit difficult, but they really helped us out with respect to calculations, right? Giving us all the log value, giving us all the values that we would require from here. So correct answer will be 4.30. Okay, or near to, we can say 4. Okay. Next is question number 74. Question number 74, hydrogen spectrum consists of several lines, spectral lines of Lyman series, has lowest energy among the Lyman series. Similarly, it consists of several spectral line in Balmer series, has lowest energy among the Balmer series. The energy of L1 is X times the energy of B1. What is X? Easy question. We have already written down the formula in one of the questions previously, right? When we are talking about the energy levels for the electrons, right, that are present in different orbits. So we are going to do the exact same thing over here, 1 by n1 square, 1 by n2 square, right? So here, as you can see, this is actually 1. Okay. So when you solve this, Z value, because they are talking about, I think, hydrogen itself, so Z value is going to be 1, right? So it is going to be 1 square. Here also it is going to be 1 square, 13.6. And here also 13.6 Z squared 43, here also 13.6 Z squared 43. We really did not have to several spectral lines. I think they are talking about hydrogen only, right? Yes. So we can take it as 1. Even if you don't, it will anyway get cancelled out over here. I would say just don't solve the complete thing, because things will get cancelled out. When you are going to take a ratio of both of them, you will get the value as 54 into 10 raised to the power of minus 1. That means your answer over here is going to be 54. Okay, let's look at the last question. The last question is Dumas method. In almost every paper we have Carius, Zelda and Dumas for sure. Every single year it comes, right? So let's look at Dumas method. What do you have to know? You just have to know the formula. Okay, in Dumas method for estimation of nitrogen, 0.50 grams of organic compound gives 70 ml of nitrogen collected at 300 Kelvin and 715 mm pressure. The percentage of nitrogen on the organic compound is. Now there is just one tiny twist that is presented over here, that we will have to use the ideal gas law, right, to find out the volume. So P1 V1 T1, P2 V2 T2 is what we are going to use here, right? Put down the values of the pressure and the volume that are presented to us. Remember, they have already given us aqueous tension. Okay, because they have given us the aqueous tension, then the P1 value that is presented is going to be 715 minus 15. You have to subtract aqueous tension, otherwise your answer will be wrong. So this is going to come out to be 700. Okay, so that we have written over here for final formula, as you guys can see, and your volume is going to be 58.67. Okay, now we are going to put it in the equation of Dumas. Dumas is percentage of nitrogen. So first of all, N2, right, which is going to be 28 divided by 22.400 because at STP. Then volume of number of N2 at STP and weight of organic compound. Both this value we have calculated, which I put it down over here. And for organic compound, they have already given us the mass. So we have put over here. Your answer is going to come out to be 14.67 because you have to write down the nearest. You will have to write down answer as 15. Okay, is 15%. All right. So these are all the questions that we have. I think the numerical questions were a little bit difficult on the difficult side. But if it is not a numerical question, if it is a organic or inorganic questions, were absolutely and very, very simple. Right. So thank you so much and have a great day.